Hi everyone, welcome to MedDeviceEngineerX again, and today we're going to go over how surgical drills are maintained and repaired. If you've ever been inside an operating theater, you'll know how important it is how surgical drills are. So they're used for cutting, shaping, and removing tissues with very extreme precision. But here's the thing, these surgical drills, they go through very intense use with every operation, and like any high performance tool, they need regular maintenance to stay effective. And in today's video, we're just going to break down exactly how surgical drills are tested, how they're maintained and repaired. And I'll just use one of the official field plant maintenance checklists I use in my job, and we're just going to go over the first one, which is preparation. So step one is preparation. So the workplace needs to be clear and all the testing equipment needs to be ready. So from the IPC console to the temperature sensors and the safety analyzer that you use, so whether it be Rigel or Fluke. So think of it like setting up your lab bench. So precision starts with organization. Next is the visual inspection. So we're going to check if the drill is free of any burrs, that the cables aren't damaged or nicked or worn, and that tracking posts aren't worn out. So make sure they're all clear, well, as much as possible. So this stage is all about spotting the obvious red flags before we go through the next step. Next step is functional testing. So here we insert the correct blade or burr for the specific handpiece model. And this is pretty obvious because you have to make sure it locks securely. If it doesn't, then it's the wrong handpiece model. What happens after this, the drill is then connected to the IPC console, which should instantly recognize the device. And then once we set the correct RPM on the IPC and the direction, we run the drill and check if the console matches the expected performance. So you should have a list of references of values within the appropriate range. And for some models, we also run a temperature check. The drill is operated for 1 minute while your temperature sensor, your thermal device, records the readings at key points. Everything has to stay below 118 degrees Fahrenheit. Anything higher could mean overheating. And what does this mean? It could risk patient safety and the damage of the device. Step 3 is the electrical safety and the final steps. So let's start with electrical safety. Not every handpiece requires this, but when it does, we measure the resistance using a safety analyzer. So whether you use a Rigel or Fluke. And the readings must fall within strict limits. For example, less than 0.09 ohms for the M series drills which Medtronic provides, or the 0.125 ohms for the VSAL models. And then of course, all engineers knows this, everything needs to be documented. The model, the serial number, test results. I normally just take pictures of it for my physical evidence. And then lastly, if needed in your workplace, the signature of the clinician or the technician you are in communication with. This then creates a full service record and ensures traceability and compliance. And then after this, the drill can go back into surgery.